Okay, so in this video, we're going to look at compound interest. Now, a compound interest question is really a percentage increase question, okay? And there is a video already on percentage increase and decrease that might be worth having a little look at just to remind yourself of how we did those, okay? But just to see how we connect percentage increases and compound interest, we're going to jump straight into an example here. Okay, so let's have a look at this example. We have 1,200 euros is invested for 3 years at 4% per annum compound interest. What will the investment amount to? So basically, we're looking at a 4% increase. Okay, when you invest money, you earn a percentage onto that amount. Okay, so it is like a percentage increase question. So in year one, we basically want to increase 1,200 euros by 4%. That's the amount we're going to earn onto it. So as I said, interest is always an increase, percentage increase question. You are always earning money when you have money in an account earning interest, okay? So to get 4% of 1,200, if you remember, we do 1,200, we multiply by the decimal 0.04, okay? And that is 48 euros. And of course, that's what we're earning. So at the end of year one in the bank account, I'm going to have 1,200 plus 48 euros, which is 1,248 euros. Because I've earned 48 euros, that's the interest I've earned. So I still have the 1,200 in that account. I've now earned 48 euros on it. So at the end of the year, I've now got 1,248 euros in the account. So at the start of year two, I have more money than what I had at the start of year one. And I'm still going to earn 4% in the second year. Again, because it's 4% per annum, which means you're going to earn 4% for every year. That's what per annum means, is per year. So again, I'm going to get 4%. So multiply by the decimal. And I have 49.92 this time I'm after earning. And of course, I'm going to add that on to the 1,248. And I'm getting 129792. So now that's how much money I have at the end of year two. I earned 49.92 interest in year two. I earned 48 euros interest in year one. So now at the start of year three, I now have 129792 in the bank. And again, I'm going to earn 4% on that. So I'm going to increase that by 4%. So calculating my 4% first. Now I'm going to round this to 2 decimal places because, of course, you always round money to 2 decimal places. This is the calculation I'm getting, 9168, and your 6 is going to make that one bump up to 2. So 2 decimal places always for money. And that's my interest that I'm after earning in year three. So I'm going to add that on to my amount. And I'm getting 1349.84. And that's what I have in the account at the end of the 3 years. Okay. Now, before I move on, I wanted to show you this way so you can see exactly what's going on and how it's related to the percentage increase. But that is a long way of doing it, okay? There is a quicker way, and I want to show you that. Okay, so if you remember from our percentage increase and decrease video, okay, I did show you in that video a quicker way of increasing an amount by a percentage. And it was looking at the percentage. If you want to add 4% on, then basically the percentage that you're looking for is always your original 100%. Add on the 4%, we are really looking for 104%. Okay, so if I have 1,200 euros and I want to get 104%, again, you multiply by the decimal, so 1.04, I am getting the 1248. Yeah? So that is getting the 4% and adding it on immediately in one step, okay? Because you're adding the percentage on with the percentages first instead, and then just getting that new percentage of the amount. So you're still ending up with the same value, you see? That's the long way around, and that's the quick way, okay? Now that's, of course, the end of year one, and then what you would do is you would take the 1248 and you would increase by 4% again, and you would get the 129792, and then you would take that 129792 and you'd multiply by 1.04, increasing it by 4% again, and we would get, of course, the 134984. All right. Now, I can do this even quicker than that. If I wanted to do that all in one quick go on the calculator, basically what I'm doing is I'm doing 1,200 times by 1.04, and then I'm timesing by 1.04 again, because whatever I get, I'm timesing by 1.04 again. Whatever I get there, I'm timesing by 1.04 again. So basically what I'm doing is 1,200 times 1.04 times 1.04 times 1.04. Now, when you have an amount times by itself again, that is basically to the power of 3. Yeah, that's what the power of 3 means. It means you're multiplying by 1.04 by itself 3 times. Okay, so if I do this on the calculator, 1200 times 1.04, and I'm going to the power of, and I'm going to put in the 3, I am getting my answer 13498. Of course, we're rounding 2 decimal places for money. 84. Okay. Now, what this leads me on to is the formula. Okay. Now, I want to show you the formula, and it's linked to this quicker way, but I do still want you to understand the long way. And the reason I want you to understand the long way is because the formula will work great for you, and it is in your log tables. And it's lovely. It's a quicker way of doing it. And that is all fine when the percentage is the same for every year, like it is in this question. But that mightn't always be the case. So it works great for you when the percentage is the same. But there may be questions that are a little bit more complicated, where your percentage changes at the end of the year, each year. Maybe you're adding more money in year 2, instead of just keeping it the same amount for 3 years. There could be lots of different things in a question that just change the complexity of it. And suddenly then your quicker way has to change. You're not able to do a straightforward one set amount by the same rate. Okay, so you just have to watch out for that. So the formula will work for you with a question like this. It's the same amount invested. We just have the time frame, same rate each year. So perfect. But the longer way is worth knowing how to do in case there's certain extra little things you need to think about. All right, we'll see that as we do some questions together. Let me introduce the formula first. So this is in your log tables. If you go to Financial Maths, page 30, here we go. Compound interest here. This is the formula here, where F is the final value and P is the principal. Principal means starting value. Now just have a little look up here. T is the time in years. I is the annual rate of interest, depreciation or growth. So that means it could be a percentage decrease or increase. In our case, with the interest questions like this, it's always percentage increase. But the I is expressed as a decimal. So for example, 8% needs to be put in as 0.08 for the I. So just watch out for that, okay? You're always doing the decimal, like we did here, the decimal version of the percentage, okay? Goes into your formula. So let's take this down. So this is F equals P for the principal, means the starting amount, 1 plus I to the power of T. T is the time. And as I said, this is page 30 of the log tables. And so in this question, we are looking for the final amount, what the investment will invest to, okay? So we are looking for F, the final amount. We have our principal value, the starting amount of money, 1,200, and then 1 plus the I is, of course, the 4% in decimal form, which is 0.04. And this is where we're getting the 1.04 from, yeah, because we want an increase, which is why we end up with 104% is what we're technically looking for, which is a decimal of 1.04. To the power of, and it is in, of course, 3 years in the account, so 3 goes there. And that is, of course, what we did there. And so on the calculator, your brackets means times, of course, so you can put in your brackets 1 plus 0.04 to the power of 3, and of course, we're getting our answer. Two decimal places is 1349.84. The answer we got here and the answer we got here. So that is it using the formula. Okay, so take a look at this example. Use the compound interest formula. So we are directed in this question to use the formula to find the compound interest which accrues on 2,800 invested for 3 years at 7.5% per annum. Per year, that means. Now, watch out with these wordy questions. Read it a couple of times just to be sure that you know exactly what you're looking for. Okay, now we need to use the compound interest formula, but we're not asked for the final amount. We're asked for the interest, okay? So we're going to have to use the final amount to figure out what was just the interest that was added on. So I'll show you that. So first thing we're going to do, of course, is take down our formula from our log tables, all right? And we're going to fill it in. So we don't know the final value. We only know the starting amount, which of course is your P, your principal. The I is the rate in decimal form. Now, 7.5% in decimal form, in other words, divide by 100, which is 0.075. Okay, it's basically 7.5 divide by 100. All right, so make sure you get that right. It's very easy with a rate like this that already has a decimal to mess up the decimal form of the percentage. So that is 0.075 and then 3 is the years. So that's the power of 3. So doing that on the calculator, I get 2,800, 1 plus 0.075 to the power of 3. And I'm getting 3,478, again, to 2 decimal places, 0.43. So the final amount is 3,478.43. Now, they don't ask me for the final amount, they ask for the interest. And what that means is if you started with 2,800 and you've ended up with 3,478.43, how much interest have you earned on that money? So what I'm going to do to figure that out is I'm going to take my final amount and subtract what I had at the start, which is 678.43. That is the interest earned on the 2,800. If your final amount at the end of 3 years works out to be that, that's what you've earned as interest on that starting amount of money. Okay, let's take a look at this question. So in this question, we have to find the compound interest earned on the investments without using the compound interest formula. Okay, so we want to do this the long way because we have to fill in lots of bits of information here in the table. All right, so this is a classic example of where we are kind of forced to do this the long way around because there's lots of answers that they're looking for. Okay, so pause the video if you feel confident with this one. If not, listen up and I'll go through it now bit by bit. So we have 400 euros at the start, okay, and it's a 6% rate, so it's going to be a percentage increase of 6%. So I'm going to do 400, and I'm going to figure out what that 6% is, so multiplying by the decimal, and I'm getting 24. The 24 is the interest. And that makes sense then that the final value is 424. I could have just spotted that, of course, from the table, but just to show you where I'm getting the 24 from. Now, Then in year 2, of course, I'm starting off now with 424 euros. And what I want to do now is increase by 6% again. So find the 6% first. So 424 times 0.06. And I'm getting 2544. Symbol here. And of course, to get the final amount, I want to add my 6% on to my 424. So add on 424, and I'm getting 449.44. And there we go. Let's take a look at this question. 4,600 was invested at 2 years, for 2 years at compound interest. If the rate for the first year was 4% and for the second year was 5%, find the total interest. Okay, not the final value. That's important to know straight away. Find the total interest for the 2 years. Okay, pause the video if you feel confident here. If not, what I will say is you have 2 different rates here, okay, which means that you will not be able to use the formula to find the amount at the end of 2 years because our rate is changing. Okay, so we're kind of forced to do a longer version here. Okay, so now if you want to pause the video, if you feel confident, pause here and let's give it a go. Otherwise, we're going to go through this now together. So 4,600 euros is what we're starting off. Okay, and this is, of course, year 1. And I want to apply a rate of 4% compound interest, which means I want to increase this amount of money by 4%. Now, I will do my little quick method of increasing by 4% by considering the percentage first. An increase of 4% is, of course, looking for 104%. So I'm going to go ahead and get 104%. So multiply by the decimal. So I have 4600 times 1.04. And I'm getting 4784. Which means that at the start of year 2, I have 4784. But this time, of course, in my second year, I have 5%. A change of rate here. So a 5% increase is, of course, I'm going to go do my percentage rate first, just to speed this thing up a little bit. I'm looking for 105% this time. Increase by 5% is looking for 105%. So multiplying by the decimal then, so I have my 4784 still up on my calculator, and I'm going to multiply by 1.05, and this time I'm getting 5023.2. So that's my amount in the account at the end of the 2 years. I'm not asked for the amount at the end of the 2 years. I'm asked for the interest earned over the 2 years. So if I started at 4,600 and ended up with a value of 5,023.20, how much money have I earned to get from that to that? So what I'm going to do now is I'm going to take 5023.20 and subtract what I had at the start, and that will leave me with 423 euros and 20 cents, which must be the interest that I earned. To get from 4,600 to 5,023.20 at the end of the 2 years means I've earned 423.20 on that amount. Let's have a look at this question here where we have a repayment, okay? I just want to show you one where you may, again, have more complexity in the question. Although my rate is the same, I am repaying some money. So what we have here is, it's a loan rather than a savings as well, okay? So this is what's important about this question. But you're still earning interest. In other words, when you take out a loan, you always have to pay back interest, which means you are going to pay back more than what you actually borrow, okay? And that's your kind of fee for being able to have the money up front. So it is still a percentage increase, okay? Even though this is a loan, because you have to pay back more, as I said, than what you borrow. So the rate is the same, but I am paying back some money at the end of the year, which is affecting my principal, okay? So this is another situation where I'm not going to be able to do the formula with this type of question because, again, there's loads of bits of information I need to fill in here in the table. So I'm going to have to do it bit by bit. And then, as I said, although the rate is staying the same, my principal, there's going to be a change. It's not going to be the final amount that's carrying on here to get the new interest. We have a change totally because of this repayment at the end. So I want to show you how a question like this works, okay? Pause the video if you want to give this a go, though, if you feel you could make a stab at it. Especially, you could be able to get these two values anyway. So pause it here if you want to give it a go. Right, so this time we're starting with 12,000 at 11%. So what I'm going to do is I'm going to work on my interest. So my interest, of course, is working at the 11%. So multiplied by decimal, 12,000 multiplied by 0.11, which is 1320. Interest. Add that on to the 12,000, of course, and I'm going to get 13,320. Now I'm paying back 5,000 euros at the end of this year. So go ahead and take away 5,000 from your 13,320, and I'm left with 8,320 euros at the start of year 2. And then I'm going to accrue interest on this. I'm not earning interest, as I think I said before. This is accruing interest. In other words, I have to pay back this interest with this kind of a loan question. But again, I'm going to multiply by the decimal. You're getting a percentage same way. It's a percentage increase question either way. So 8320 times 0.11 is 91520. That's the interest that you're accruing in year 2, which you're going to have to add on to 8320. And I am getting 923520. The company repaid 5,000 in the first year. Use the table below to find out how much the company owed at the end of the second year. So there we go. That is the final amount owed at the end of the second year. I was just checking there wasn't another repayment there, but there's not. That is highlighted there, that box. So that is actually my final answer. Okay, let's take a look at this question. Now, this question is asking me to use the compound interest formula to find the final amount. Correct their cent of each of the following investments. All right, so let's get our compound interest formula written up here. All right, from our log tables, of course. F is our final value, P is our principal value, what we're starting off with. I always has to be put in decimal form for the rate, remember, and T is the time. Here in this case, we're talking about years. So for part I am looking for the final amount. So looking for the F, starting off with 600 euros, and I have a rate of 5% in decimal form is 0.05, and for 2 years, so it's 2. So I'll do that on my calculator. 600, 1 plus 0.05 to the power of 2. So that's what I have typed in there, and I'm getting 661.50. Get your euro sign. There we go. Okay, pause the video and try part 2 for yourself now. So part 2 then, again, I'm looking for the final amount, but this time I'm starting off with 1,800. The interest rate in decimal form is 0.09%, and 2 years again, so a power of 2. So again, my calculator, 1,800, 1 plus 0.09 to the power of 2. That's what I have there. And I'm getting 21385. Okay, take a look at this question. If 650 euros amounts to 702 euros in 1 year, find the rate. Okay, so I'm going to use my compound interest formula here to help me out. Okay, I'm going to fill in the bits that I know and then hopefully be able to work my way backwards to find the rate. So the final amount, so it amounts to 702. That's my final amount. It starts at 650, which is my principal amount. I know that that's 1, obviously, plus I don't know the rate, so I can't fill that in. But I do know that it is 1 year, so that's the power 1. Okay, so what I end up with is this, and what I want to try and figure out is the I. So this is the power of 1, so that's just going to be 1 plus I. And I'm going to try and break down this equation to get what that I is. So the first thing I'm going to look to get rid of is the 650 here, which is being multiplied on this side. So in order to get rid of something that's being multiplied, I'm going to divide, so it cancels. But of course, if I divide on the right, I'm going to have to divide also on the left. So 702 divided by 650 works out to be 1.08. And that must be equal to the 1 plus I. Of course, take away 1 from both sides there, and I end up with 0.08 is equal to I. I, of course, is my rate, but is my rate in decimal form, so it must have been an 8% interest rate, of course, if it's 0.08 in decimal form. So there we go. So fill in what you know into your formula, and then literally just break down the equation to get that missing piece. Okay, and here's another question where we are going to use our compound interest formula to find a missing piece of information. Okay, so pause the video here if you want to give this one a go. I'm going to take down my compound interest formula here again, and I'm going to put in all the bits of information. I am asked, what sum of money invested at 4% per annum compound interest will amount to 3,149 euros and 62 cents after 3 years. So this is what it's amounting to, which means that is my final value, 3,149.62. So I'm going to put that in for the F. The P is the bit I don't know. I don't know the initial sum of money that was invested, the principal amount, in other words. I do know the rate, however, in decimal form is, of course, 0.04. And the time I know, of course, is 3 years. So I can also fill in my T. So there we go. I've everything filled in that I know, and now I'm going to try and figure out what this missing piece. So I'm going to evaluate this first. So on the left-hand side, let's keep our 3,149.62. And then here, what I'm going to do, so since I want to break this equation down so that I'm left with just the P, I basically want to get rid of all of this here in order to get the P on its own, all right, on the right-hand side. And since all of this here is being multiplied to the P, what I'm going to do is I'm going to literally divide by that. And if I divide by that on the right, I'm going to divide by that on the left. That will get rid of all of that. Leave me with the P. And on the calculator now, I'm going to do this calculation. So I'm going to get the fraction button up on my calculator. And I'm going to put in 3,149.62. And underneath, I'm going to put in brackets, 1 plus 0.04, close the bracket, to the power of 3. So there we go. I have it typed in exactly the way I have it. And I'm going to press equals. And I'm getting 2,800 to 2 decimal places is just that. That was my starting amount of money. Okay, so this is the last question I want to do with you, and this is a question that looks at a depreciation, all right? So this is the first question that we have here that we don't have a percentage increase, all right? This time we are losing money. This word depreciate means you're losing a certain percentage value, all right? So this machine depreciates in value by 10% per annum. If the machine is worth 58,320 at the end of the 3 years, find its value when new. Okay, now we can use this formula here to help ourselves, because the only thing that I need to tweak in this formula for depreciation is that plus to a minus, okay? And actually, if you check your log tables on page 30, if you come down here to the depreciation section, you'll see that that's exactly the way they have it here. If you are looking for a percentage increase on something and you're compounding it, then it's a plus. But if it's a depreciation and it's something, again, that's having an effect year on year and compounding it, it's a minus the interest rate, that percentage you're going to be taking away. All right, so that's the only thing I need to consider with a depreciation question. So now I'm going to fill in what I know. It is worth 58,320 at the end. Now that's key. At the end means that is my final amount. So I'm putting that in for F. I don't know what the amount was at the start when it was new. So that's the bit I'm looking for. But of course I can fill in 1 minus the I is the rate in decimal form, is 0.10. 10% of the decimal is 0.10. And of course, the time is 3 years. So there we go. Using the question, pulling out all the bits of information, slotting it into my depreciation formula. And now this time, again, I want to get the P on its own. So I want to get rid of all of this on the right-hand side. And of course, to get rid of all of that, since it's being multiplied, that's what I'm going to divide by. Now, do you see the way I came down to my next line to do this work? That is useful to do, because if I go ahead and make a mistake at this point, at least I have that filled in correctly. And you're going to get loads of marks from the examiner when they see that. You start doing something to that line and doing something incorrectly, then you're going to lose marks. You want to have that line clear as day, untouched, so that the examiner can see, well, you're after taking all the information, you've subbed it into the correct formula. That's the easy bit. It's the manipulation now that's tricky, but at least you have got the vast majority of the marks for just doing that bit there, okay? So that's why I would suggest come down to the next line to start doing your working out to that, just in case you make an error now as we go forward. But you know now you've got those marks saved. P on its own, now on the right-hand side, I'm after getting rid of the 1 minus 0.10 to the power of 3, because it's being multiplied. I've divided by it. If I divide by it on the right, I divide by it on the left. And of course, on the calculator, I'm going to do this calculation here. So getting my fraction button up, I'm putting in 58320, and coming down here, I am putting in bracket 1 minus 0.10, close the bracket, to the power of 3, and I'm getting 80,000. And don't forget your euro symbol. 80,000 was the principal value of that machine.